Okay, welcome to another video by Tactical Technician from Diagnation. Today I want to talk about fuel sender dynamic testing. This is not something we see that's a common. A lot of times when we think about a fuel sender, we think about the ohm meter and we directly measure the resistive value of the sender, or we could rely on scan data. But this is a different venue. In this situation, we're going to dynamically check the fuel sender in action. Basically, we're going to have we look at your schematic. Basically, we'll talk about the schematic. The upper left there, that's the instrument cluster where the fuel gauge is, and that is controlled by logic, and the logic gets its information from the sending unit. That's the sending unit in the tank right there, and that changes resistance as the float level changes. It's basically a potentiometer type resistive component that changes resistance as I said, as the fuel level goes up and down. We're going to be looking at this signal on two channels. Channel A, orange, is a micro clamp, and we're checking the current flowing to the fuel sender. Channel C, green, is the voltage drop across the sender. How I'm going to do this is that this has been recorded. This has been captured already. I went to the gas tank, the gas station. I kept the car running. I had the scope set up like this, and I proceeded to fill the tank from almost empty to full, and I captured the action of the float moving from the bottom to the top. And we're going to look at current flowing, and we're going to look at voltage drop as the resistance changes. One thing I could say is that as the gas tank fills, the resistive value gets less and less. So we'll see that on the scope capture. So basically, I will take you to the scope, and then I'll tell you everything as I did it the other day at the gas station, and we'll take a look at these at this capture. So here we go. Okay, you can see this. Okay, you can see the scope right now, and we're going to have I'm at a very long time base. I'm at 5 seconds per division, which is pretty much the duration of the time I was filling the vehicle up. And I'll show you some different things along the way, and we'll take a look and analyze how we could use this method if we had a fuel sending unit under suspicion, where it was intermittent, where it wasn't always proving to be accurate, where the customer was complaining, something like that. So nonetheless, here we go. I will go, keep your eye on the screen, and I will explain what's going on here. Also, if I forgot to mention, take a little snapshot of the illustration I showed you about 2 minutes ago. That may make it easier to understand everything. We're only looking at two channels. So basically, here's the capture. It's about, I guess if we're at 5 seconds per division, that would be 50 seconds twice plus a little bit, maybe about 100 seconds of action here. So basically, you can see right here, this is me now at the beginning of the capture. Green is our voltage drop across the sender, and orange is our current flowing through the sender. So if we look at this section here, this is the voltage available at the sender. That's about 9.5 volts. This is a complete circuit with current flowing. There is some voltage drop up at the cluster. It's a kind of an electronic cluster, but nonetheless there are some resistors up there which are normal. So we're gonna see with the car running and current flowing through the sender about 9.5 volts at the that's the voltage available at the sender. The current flowing to the sender, okay, from the cluster is going to be about 15.5 milliamps. The conversion is equal on this clamp, this micro clamp. So basically right here is when I'm idling at the gas pump. I had swiped my credit card, and I was ready to pull the nozzle in the fill hole right around here, and right here is where I pulled the trigger on the nozzle, where I started to put fuel in the gas tank. And let's stretch that a little bit. We get more granularity on that, and there's where gas starts to flow into the tank. And I want to show you something what I did to see some action reaction here. This area right here, you see the action? You see that that those little undulations? I created that. I sort of, as I was very careful to, I was holding the nozzle in the tank. I didn't want it to pop out. I bounced on the rear of the trunk as best as I could. So obviously you see that was this right here is the float moving up and down. I created some waves in the tank, if you will, and that changed the resistiveness of the center in the tank, and that's why we see these kind of highs and lows there. Anyway, I just wanted to prove that out to show the sensitivity of this technique. So I'm continuing to fill the tank, and as we can see, as the resistance gets less, as the tank fills, we will flow more current, which is basically Ohm's law. We're starting to climb on the current. Right here, we're at 17 milliamps. Right here, we're at 22 milliamps. Right here, we're at 26 milliamps. And as our resistance gets less, our current goes up. Our voltage drop across the sending unit gets less. So we're at 9.4 volts here. We're at 8.339 there. We're at 7.1 here. So we can see the Ohm's law very dynamically, very natural right here in this technique. So our current is going up. I'm continuing to hold my hand on the trigger of that gas pump. And my next shot, I did something here to sort of create a little gremlin to see how we can use this to our advantage. You see this, let me shrink this so we can kind of get it back down to norm. Okay, oh, okay. I sent a little troll into the gas tank to screw up the sender a little bit to create an intermittent issue with that sending unit. And that's what happens if we had a bad contact spot right in a certain section of that fuel sender. We'd see something like this. So the advantage of this is we're checking it dynamically. We're not using the ohm meter, and this is very natural. So you can see that cutout right there. So I created that, and then it went away. So that's just something to bear in mind. This is a really good technique to catch a glitch like that. So anyway, I'm continuing to hold my hand on the nozzle, and it gets up, up, up. The current's going up because the resistance is going at the float. Right here, the float is just about at the top, and it's almost ready to click off. Current rising and voltage dropping because our resistance is getting less. And I did one more thing here just for grins. You can see right here, I did another bounce job on the side of on the trunk, and you can see the resistance going up. That's the float moving up and down in the gas tank. So anyway, just bear in mind this is a really cool technique. There's so many ways we can use this technique. It's I guess pretty much it's unintrusive as far as the current, and we're watching the action of that float ball in the gas tank change as the resistance changes, and a good way to also catch an intermittent issue with the sending unit. Anyway, signing off here. Hope you enjoyed the video, and all the best.